How's everybody today?
I'm fine.
Bunyi macam I'm fine, tak bunyi excited, tak bunyi macam ala-ala hidup mati. Apa kata orang kata hidup segan mati tak mahu, macam itu ke? How are you coping with the semester? Okay.
So far, so good.
So far so good. Selalu tanya student macam tu lah. Okay madam, alhamdulillah so far so good. Dia tengok result, ya Allah apa jadi ni.
Not very good.
Apa not very good?
The result.
The result suddenly not very good. Don't know what happened. Okay lah. So biasanya macam tu. Hopefully out in your fourth year you should already know whether the semester is good or no. Maknanya dia macam like a what do you call it, like ada trigger lah. So macam awak dah tahu semester, that semester will be a good semester or no. If it's not good, you should start doing something to make it good. Okay, so let's go. Kita kat mana last time? Kita start dengan tazkirah lah. Boleh tak? Siapa nak bagi tazkirah di sini? Ada volunteer nak bagi tazkirah? Cikgu UIA kan hebat-hebat belaka. Anybody? Ada? You know, in Islam, apa hakul Muslim alal Muslim? Apakah wajibat? Apakah hak Muslim kepada Muslim? Siapa tahu? Mana kita ni semua Muslim, right? So kita ada hak on from another Muslim. Apa hak-hak tu? Without Google. Jangan Google. Awak tahu tak?
Berbuat baik antara Muslim.
Apa? Salihin?
Berbuat baik sesama sendiri.
Oh, apa dalil awak ya?
Cakap kita.
Macam tak je, you know. Okay, lagi. Buat balik baik tu terlalu general. Dia ada very specific. Awak tak pernah dengar pasal tu? Hak-hak Muslim terhadap Muslim yang lain. Student UIA, 4th year, engineering. Dia dah go through macam-macam usrah, budi lah, halaqah, study circle lah. Islamic worldview lah. UNGS, UNGS lah. So, ada? Bagilah satu yang satu pun tak boleh bagi, dia ada banyak. Rasa 7 ke tak silap.
Menghormati jiran. Madam, kata.
Menghormati jiran tu whether dia Muslim ke tak Muslim, kita kena be good to our neighbor. Okay, so this is hakul Muslim alal Muslim. Hak orang Islam ke atas orang Islam yang lain. Kalau jiran ni walaupun dia bukan Islam, still kita kena buat baik. So tak termasuk dalam ni lah. Tapi good try. Ada lagi yang nak try?
Saya nak kata yang mencegah kemungkaran dengan kuasa, kalau tak boleh dengan mulut atau tak boleh dengan hati. Tapi yang tu pun saya untuk semua orang juga kan. Bukan antara Muslim saja.
Semua orang juga. Alah awak ni pun. I give you 1 minute to Google. At least awak tahulah, at least grad UIA ni orang tanya. Dosa tahu kalau kita tak buat hak Muslim ni. Bila dia tak, dia tu hak dia. Kalau kita tak bagi hak. Sekejap. Saya duk hoping awak duk bagi tazkirah saya pula bagi tazkirah kau. Alah awak ni.
Madam ada 6 je madam.
Ada 6, okey, apa benda?
Mengucapkan salam. Give salam.
So number 1, kalau hak dia ialah untuk menjawab salam, bagi salam, menjawab salam. Betul?
Oh yang ni.
Memenuhi undangan.
Okey.
Invitation.
Kalau tak buat ni dosa tau. Mana kalau kita orang bagi salam tak jawab salam, dosa. Kalau orang ajak kita memenuhi undangan, macam for example Azam ajak kita pergi makan rumah dia dengan harapan satu hari, kita tak pergi. So dosa kita tak pergi. Lagi?
Memberi nasihat apabila diminta. Oh, betul lah madam.
Memberi nasihat bila minta. Ni lah saya suruh bagi tazkirah, awak semua telah berdosa pada saya sebab awak tak bagi tazkirah, saya kata. So salah satu hak muslim dan muslim yang biasa kita tak tahu kan, dosa tau kalau tiba saya pergi salihin. Tolong bagi nasihat ke saya hari ni. Alah madam, tak boleh madam. Kalau awak kata gitu dosa. Sebab hak kena bagi advice. For example, saya tengah ada kesusahan macam ni, for example awak pergi ke another muslim, awak kena is dosa kalau awak tak nasihat. Walaupun kalau kata macam tak tahu nak nasihat pun, awak kena kata okay, saya tak tahu nasihat tapi mungkin boleh you kata jumpa orang ni boleh tolong ke, macam tu. So antara hak muslim dan muslim ialah bila dia datang, kalau orang faham Islam, dia takkan tolak orang kalau bagi advice. Maknanya kalau kita duk tolak tu, kita tak faham Islam lah tu. Kita ilmu pun cetek, belajar pun tak nak, pergi usrah ekstra pun tak nak, pergi talk pun tak nak, semua tak ada. So kita do expect kita jadi good Muslim. Tapi saya ada kawan-kawan yang biasanya orang yang ada ilmu lah. Bila kalau saya pergi saja, saya macam bilik saya sebelah saya tu Prof Aisyah. Tahu kenal Prof Aisyah?
Nan.
Prof Aisyah tu sebelah bilik saya. So she's a good friend. So kalau saya tiba-tiba saya wang ke, aku pernah wang lah, so masa down, so macam tak tahu hala, saya akan pergi bilik dia, Assalamualaikum Prof. Yes, come sister. Saya akan just kata, can you give me advice? Duduk gitu ya. Dia akan start cakap. Basically dia akan bagi tazkirah. So sebab dia tahu kalau saya minta macam tu, wajib untuk dia kalau pergi kat orang Melayu minta macam tu, tak payahlah orang ni, kalau orang Melayu lah, dia tak faham agama, dia akan jawab macam-macam alasan. Orang yang faham agama, dia tak boleh kata no sebab dia terdosa. Apa lagi, Azam?
Boleh pula madam.
Apa?
Okey. Bila
Jika dia sakit maka kunjungilah dia.
Apa?
Jika dia sakit maka kunjungilah dia.
Ya, suatu hak dia kalau sakit, macam kalau kita tak adalah duk payah nak pergi kan, tapi kalau dekat-dekat tu, kalau kita boleh pergi tu, pergilah, hak dia. Kalau dia sakit, and then dia ada adab melawat orang sakit, jangan duduk situ sejam, 2 jam.
COVID-19. COVID. Tak boleh nak melawat orang COVID, tak boleh.
COVID tak boleh, tapi generally kita kalau kawan kita sakit dekat mahalah, kita pergi tak visit. Tapi kita sibuk kerja kita kan. Kita bukan nak pergi melawat dia, tanya dia cukup makan ke tak. That is Islam. Tak semesti dia kawan kita, tak kawan kita. Ni hakul muslim alal muslim. Nama je Islam, dia ada hak atas kita. Walaupun dia tu bukan kawan kita. Awak dengar kat mahalah awak ada seorang ni sakit, jiran ke siapa-siapa sakit, dia orang Islam, awak kena pergi and tanya dia apa khabar, apa semua. Rupanya dia tak makan ke. Dia tak tahu kawan-kawan kita kat mahalah demam, tak larat nak pergi makan, tak ada orang pun pergi tanya. Ni it always happen dengan, tak tahu, sisters happens ada dalam mahalah. Okey je juga kan. Nasi-nasi tapi brother selalu saya tanya, kata awak sakit demam ada orang bagi makan, ada orang datang makan, tak ada madam, saya seorang-seorang je. Sedih betul je hidup ni, Kenapa je macam tu? Ada lagi? Berapa dah kita?
Last one, jika dia meninggal dunia maka ikutilah jenazah dia.
Ya. Kalau dia
madam tak dengar madam.
Ya. Dia terputus-putus.
Kenapa tak dengar? Saya cek internet okey je.
Okey.
Dengar tak?
Yep.
Kenapa ada seorang nama Soleh ni, saya remove ya? Okay. Apa lagi? Itulah. So jadi maknanya itulah hakul muslim alal muslim. So kalau kita nama kita orang Islam, maka kita kena tahu hak-hak orang Islam lain terhadap kita, and kita tahu hak kita juga. So kita boleh pergi ke orang kata give me advice, you should give me advice. Right? Okay. So itulah tazkirahnya. I'm hoping you give me tazkirah apa next time lah. Kalau saya kata bagi tazkirah dosa awak tak tahu lagi. Saya kata give me advice. So get ready. Okay. So kita kat mana last time?
Madam.
Ya.
Madam remove saya punya satu lagi
Kenapa?
Sebab saya satu lagi saya tengok dekat PC. Yang ni saya dekat tengok handphone. So,
Oh,
kalau
ya.
handphone ah,
So,
tak
awak tak boleh masuk balik. So, once remove, you cannot join back. Sebab awak tak beritahu
Oh.
saya tadi. Saya tanya Soleh ni, saya disebut tak Soleh tu apa, saya remove, awak tak kata apa-apa.
Oh ya.
So, macam mana? Macam mana buat? Macam mana saya nak kena bagi awak masuk balik? Apa email awak? Okay, saya invite. Email. Awak copy kat chat your email. Okay, kat mana kita?
Last one that we did was drive assisted generation and recombination. Yeah.
Okay. So kita dah habis slide 1. Habis tak?
Dah habis.
Yeah, Madam said last session is the last one for the question, and for this session we're moving to the next slide.
Okay, let's go to the next slide. Solehin, mana email awak sebelum saya buka share screen ni? Saya tak nampak dah chat nanti.
Madam.
Apa maksud Soleh Saumo ni?
Ha?
Apa maksud?
Semua nama nenek saya.
Nama nenek?
Ha.
Nenek awak orang apa? Bangsa apa? Pelik
Negeri
sekali.
9.
Negeri Sembilan?
Ha.
Itu biasa nama orang Negeri Sembilan
Tak, nama orang dulu-dulu kan banyak.
Madam,
Pelik sikit.
madam, excuse me, I need to pick up the call.
Okey lah, sibuk. Okey lah. Siapa je lah. Kat mana saya invite, copy. Macam mana saya invite boleh ni? So, choose your email service. I don't know, macam tak ada apa je ni.
So, okay, Madam, kalau tak dapat tak apalah. Saya tengok dekat handphone je. Boleh zoom.
Saya copy invitation tu je, sama je kan. Kalau saya bagi copy invitation tadi. Saya nak add awak tu tak boleh.
Tak apa, Madam. Saya tengok dekat sini je.
Okey lah. So lain kali beritahu awal.
Alright, Madam.
Dan saya tak tahu kenapa sekarang ni, kalau saya remove, dia boleh masuk balik. Mesti ada setting sama ya. Bila saya remove dia masuk balik. Agaknya dia punya security. Kalau you know banyak cases orang jahat dia panggil bombing, dia masuk lepas tu dia akan buat, dia tunjuk gambar tak apa-apa, lepas tu kalau kita remove dia, kita block, kita remove dia boleh masuk balik. Sebab tu agaknya dia buat tak boleh masuk balik ni. Okay, I will share my screen now. Nampak? Okay, intention. Okay, let's go through a little bit of hadith. Hadith number 1, where Umar al-Khattab was on the pulpit and said, Messenger of Allah sallallahu alaihi wasallam saying, verily, deeds are only with intentions. Verily, every person will get rewarded only for what they intended. Therefore, whoever emigrated for worldly reasons or for a woman, then his emigration is for that to which he has emigrated. Sahih Bukhari. Innamal a'malu binniyat wa innama likulli imri'in ma nawa. Fa in kanat hijratuhu lidunya yusibuha aw imra'atin yankihuha fa hijratun ila ma hajara ilaih. Sila hafal hadis ni ya. So hadis ni menceritakan tentang kepentingan niat. Dan kalau mana-mana buku hadis pun generally they will put this hadith as the first hadith when they want to give syarah to any, because this is the most important hadith. Biasanya kalau buku hadith dia akan letak ikut turutan kepentingan hadith. So hadith ni is a reminder for us, so we can all be here in our online class. 6 of you, 6 masuk apa Faiz 7, 1 kita berapa orang kita, I think 7 of you. And when we go out of this class, I always tell my students, kita keluar kelas ni, kita habis malaikat nak mencatat pahala tu, masing-masing pahala dia tak sama. Okay, mungkin pahala Azam lebih daripada pahala Faiz ke, pahala Solihin lebih daripada pahala Najwa ke. So kenapa dia tak sama? Sebab pahala tu dia akan, kalau kita engineer, dia akan berkadar terus. Is in direct relation to the intention, the purity of the intention, keikhlasan. So ikhlas ni dia ada degree. Ada orang 100% ikhlas. You know, saya tolong awak ni ikhlas kerana Allah. You know, what does it mean? It means that we don't ask, or we don't hoping anything, nothing other than Allah's pleasure. That's 100%. Tak ada benda lain. Okay. So tapi kita mungkin datang juga sebab takut ke madam atau kena bar, takut kena bar. Benda-benda macam tu macam dia akan kurangkan you know, kenapa dia lari ni? Okay, dia akan kurangkan purity of ikhlas, our intention. So kita pun macam itulah, kita keluar sebab tu. Padahal senang je, bukan yang susah pun. We just need to purify our intention every time, for everything. Semayang macam gitu juga. You will get based on how much pure your intention, do it for the sake of Allah ke, sebab tak nak mak marah ke. Okay. And for example, belajar pun macam tu juga. Belajar, anything that you do, research ke, you will get this dunia. Sebab because this hadis say, therefore, okay, this hadis say, therefore whoever emigrate for worldly reasons or for women. Interesting kan? Siapa tahu cerita hadis ni, kenapa ada women kat sini? Sudah UIA yang hebat-hebat belaka. Why ada women kat sini? Ya, sudah UIA yang buat macam ni. Saya tak grad UIA pun, you know. Saya grad UK. Awak UIA. So nobody knows ke awak segan? Tak nak beritahu saya?
Ingat detail, madam.
Tak ingat detail? Apa yang awak ingat?
Yang saya ingat ada seorang ni, dia hijrah sebab dia nak berkahwin.
Kenapa dia, apa cerita dia awak tak ingat lah? Macam mana cerita dia? Siapa tahu cerita dia? Najwa tahu ke? Ustazah Najwa tahu? Ustazah?
Saya macam tak kot.
Ustazah Aina pula. Aina?
Tak tahu.
Okay. The story is, ada sahabat ni, seorang sahabat ni, dia, semua orang berhijrah. Berhijrah tu jadi wajib, you know, at that time, kena daripada Mekah ke Madinah. Because Rasulullah SAW bagi arahan semua orang Islam berhijrah. Lepas tu ada seorang lelaki ni, dia minat ke seorang perempuan. So dia minat ke seorang sahabat ni, dia minat ke seorang perempuan ni. So perempuan ni baik. Perempuan ni memang dia memang nak follow Allah dan Rasulnya. So dia kata memang dia akan berhijrah. So dia nak pergi hijrah. So apa ni, tapi hak lelaki ni nak kahwin dengan perempuan ni. Perempuan ni macam bagi syarat, kalau awak nak kahwin dengan saya, awak kena berhijrah. Sebab dia tahu hak lelaki tu macam tak nak berhijrah lah. Macam iman dia tak berapa strong sangat. So macam, tapi dia suka perempuan ni. So perempuan ni bagi syarat, if you want to marry me, kamu berhijrah lah. Maka in the end, lelaki tu pun berhijrah. And Rasulullah SAW tahu pasal tu and come up with this hadis. Dan terkeluarlah hadis ni. Siapa-siapa yang berhijrah kerana dunia, apa-apa sebab dunia, worldly reason, anything pasal dunia, pasal duit, pasal harta, pasal manusia. Okay, kita belajar sebab duit, harta dan manusia, dapatlah duit, harta dan manusia. Tapi kalau kita berhijrah sebab perempuan, so in the end dia berhijrah sebab perempuan, maka dia dapatlah perempuan tu. Then his immigration is for that which he has immigrated. Maknanya dia dapat tu je lah. So sangatlah rugi, sedangkan dia membuat hijrah tu juga bersama sahabat-sahabat yang lain. Tapi dia intention dia, niat dia bukan kerana Allah. Dia niat tu dia nak kahwin dengan perempuan tu. And dia dapat tak? Dapat. Sebab tu dah hadis yang kata kalau kita intention untuk dunia, kita dapat tak dunia? Dapat. Tapi kita dapat dunia saja. Kita dapat dunia dan akhirat. Sedangkan dalam hidup ni kita boleh dapat dunia dan akhirat. So kita pilihlah. Kita nak dunia dan akhirat, kita nak jadi orang bodoh dapat dunia saja ke? Ataupun with the same thing, just purify our intention, kita akan dapat dua-dua, dunia dan akhirat. Okay, sedangkan akhirat tu wabi'sal masir, sedangkan akhirat tu tempat yang lebih baik bandingkan dunia. Okay, so sama-samalah kita betulkan niat kita dah minggu keberapa dah ni. Betulkan niat kita, kenapa kita belajar, kenapa kita duduk kat UIA, kenapa kita suffer belajar semua ni, adakah untuk dunia? Adakah salah untuk dunia sahaja? Tidak, sahaja salah. It should be, adakah salah kerana dunia? Madam, saya belajar ni sebab saya nak dapat degree, saya nak kerja, so that gaji saya dapat gaji elok. Salah ke tak salah?
Salah madam.
Tak salah.
Dia tak salah, tapi dia tidak, macam mana, dia tak salah tapi tak dapatlah semua. Why not you put
Full package.
Dia ada number 1 kerana Allah. So number 2, ya Allah kerana Allah, dan because of this, tolonglah bantu aku dapat yang terbaik so that aku boleh dapat. Sebab bila kita nak kerja, kita nak hidup tu pun Allah yang suruh kita cari. Tapi intention number 1 kita tu apa? Untuk please Allah ke cari duit? Tu yang Allah akan question kita ke akhirat kelak. Okay? So,
Macam mana kita nak tahu madam?
macam mana kita nak tahu apa?
Kerana Allah, sebab nanti ada juga rasa macam nanti nak duit, nanti nak kerja.
Sebab tu dia macam, sebab tu number 1 kalau boleh, sebab tu ada hadis lain kata kalau kita kejar akhirat, tak ingat hadis ke kata-kata sahabat, kalau kita kejar akhirat, dunia akan kejar kita. So maknanya kalau kita buat kerana Allah dan Rasulnya, kalau kita belajar ni sebab Allah suruh, this is fardu kifayah, I will try my best, dan dunia tu akan datang. Awak tak payah minta pun Allah akan bagi. Tapi kalau minta pun boleh. So macam dia kata, ya Allah, kau buat ni, aku belajar ni kerana Allah, I'm trying my best for your sake, saya amanah menjadi khalifah, saya kena belajar ilmu-ilmu ni sebaik mungkin. Dan tu number 1. Dan Allah bantulah aku untuk hidup dalam dunia ni dengan keredaanmu, mendapat a good job untuk menyara keluarga saya. So tapi number 1 tu macam nak tahu, you kena always betulkan niat lah. Sebab tu niat ni dia bukan one off dia kan macam tiap-tiap hari. Sebab tu kalau kita semayang, setiap kali semayang kita kena berniat. Macam tu juga belajar ni, ingat niat awal-awal masuk degree je. Tak, dia macam kalau boleh setiap hari tu kita betulkan niat kita, kenapa kita belajar. Pergi exam pun aku buat, ya Allah aku buat exam ni kerana-Mu. Pernah ke fikir macam tu? Aku berjuang dalam belajar ni kerana Allah. So then you get the pahala. Kalau mati pun, awak akan mati syahid. Mati dalam belajar ni kan. And then awak tak tahu mati ke tak, kita tak tahu bila kita mati. Tapi kalau ni awak untuk dapat dunia, untuk just get a good CGPA, dan awak mati sia-sia, tak dapatlah mati syahid tersebut. Maka macam nak tahu, kena always go back to your heart and ask yourself, why do you study? And then kalau heart awak jawab benda lain, awak didik your heart. Kata aku belajar kerana Allah. So bila awak belajar kerana Allah, takkanlah awak buat benda-benda lebih kurang. Takkanlah awak cheating. Awak buat kerana Allah, takkanlah awak buat lebih kurang. Kenapa awak cheating? Kenapa awak tak belajar sungguh-sungguh? Sedangkan awak nak mempersembahkan ni kepada Tuhan sekalian alam. Betul tak? So bila you have the right intention, everything will fall into place. Dan awak akan nampak keberkatan, bantuan Allah dalam hidup. Okey, Salihin.
Okay, madam. Jelas. Thank you.
Okay. So kita masuk ke mobility. Right, so apa benda yang slide nombor 2, mobility. Sekejap, sebelum kita ke nombor 2, saya go very fast on slide nombor 1 kot lah, ada termis apa-apa. Sebab tiba-tiba keluar dalam exam. Ni pun kita tak go through ni. IN mission, tak tahu ada masa kita buat apa tu. Okay, dah. So kita need to know the difference between tiga ni. We went through that. Kita dah go through yang ni. Lattice constant dah. Lattice dah. Balance band, compound. Okay, Fermi level dah. Intrinsic semiconductor dah. Effect of temperature dah. We went through the doping. What is doping? Extrinsic dah. Donor. Apa lagi? Yang ni dah. Okay. The drawing of the Fermi level for intrinsic, extrinsic pun dah. Okay dah. Finish. Okay, so yang slide nombor 2 ni pun dia macam terkabur sikit. Mobility, conductivity, diffusion. Okay. Okay, let's go through mobility. What is mobility? Okay. When you have a piece of semiconductor and you have the electron moving, right? If there's no electric field, there's no voltage applied to the the semiconductor material, will there be any current? If there's no electric field or voltages applied to the semiconductor material, will there be current or no? Ada current ke tak?
No.
Huh?
Oh.
Najwa ada ke tak Najwa? Najwa? Allah, stuck pula Najwa. Ha? Ada ke tak Najwa?
Electron ada movement of electron.
Awak ni jawab ke tak? Saya tak dengar. Your internet is pretty bad. Is there any current or no? Okay, kita tidak mendengar.
Ada.
Ada current? Oh, Najwa kata ada current. Sorry, ada current. Salihin ada current ke tak? Salihin?
Saya jawab no tadi.
Awak jawab no. Kenapa no? Najwa kata ada.
Sebab tak ada voltage.
Kenapa Najwa jawab ada, tapi sebab internet awak, kalau awak jawab pun saya tak dengar awaknya. Okay. So
Saya
so
ke Najwa?
tak. Awak saya dengar, Najwa tu saya tak dengar. Kalau saya nak tanya dia jawab kenapa ya pun saya pun tak tahu. Internet pun saya tak dengar. Kalau tu you type Najwa, why you think there's a current? But the answer is, sajalah, the answer is actually no current. Macam tak pos, mesti saja je saya tanya soalan basic macam ni je nak check you. Risau saya bila awak kata ada current. So ni faham ke tak? So this is a piece of material, semiconductor material. We don't apply anything to it. Takkanlah saya kena electric shock kot. Right? There's no current. Right? But okay, next question, Solihin. If this is a semiconductor material, is there any electron moving moving in this semiconductor material?
Yes.
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 How? Why?
Because there is free carrier in there.
Okay. So where does the free carriers coming from?
From the band, electron valence band dengan conductor band. There's free carrier in there.
Where does the free carriers coming from?
Electron from valence band and hole from conductor band.
How do you get the free carriers?
Mm. How do we get?
Doping.
Okay, doping say this is intrinsic. So how do you get the free carriers?
Surrounding temperature.
Okay, so what's the process to get this free carrier?
Oh, sorry.
One.
Generation.
Apa?
Generation.
So you get free carriers to generation electron.
Excitation.
So Solihin punya ayat tu tak lengkap. Kalau jawab macam tu mungkin saya tak boleh markah pun dalam final exam ke. You need to say the electrons are being excited from the valence band to the conduction band. Tak boleh kata electron tu daripada valence band sahaja. It doesn't complete the story. Okay. So yes, there's a free carriers, but the free carriers are moving in random. There's no net movement if there's no electric field applied. Okay, so now kita tu saja saya recap. Nak tanya kalau yang tu pun awak tak ingat ataupun terconfused, habislah kita in the future. So now let's apply apa kita kata tu electric field. What is electric field? Anybody? What is electric field?
The area where there's electric force.
The area where there's electric force. How do you get electric force?
With applying voltage.
Okay. So electric field, you got it from when you apply voltage. So electric field is basically voltage over distance. Whenever you have a voltage applied and you across a distance, you will get electric field. Okay, as simple as that. So it's a direct relation. You increase the voltage, you increase the electric field. So, but it's also inversely proportional to the distance. So that's electric field. So if we apply electric field, it means that we apply like positive over here, negative over here, and then because there's a distance of this distance d over here, you have electric field across it. So then the electron will be attracted to go there, right? So mobility is net movement of charge. How well, so this is the definition of mobility. How well particle will move due to electric field. Because when we saya draw. Okay, you have to remember when the electron wants to move to here, so that kita positive, that negative over here. When the electron wants to move to the right, you will have to go through the semiconductor material. So the semiconductor material ada apa dalam ni? Dalam semiconductor material ni ada apa? Selain daripada carrier?
Hole.
Carrier tu electron hole lah. Selain daripada carrier.
Atom.
Okay,
G-gap.
ada atom. So electron is part of the atom. Apa yang ada lagi?
Defects.
Dia ada nucleus tu kan, which is from the atom. So setiap atom ni ada yang electron will be loose, ada yang electron will be there. Okay, so saya tak draw. We are not drawing that each atom ada orbit macam tu, tapi kita tak draw. Basically semua you have atom and some of the electron or the carriers will move. So you have to imagine this electron here will need to go over there and has to go through this lattice. So if you driving a car, okay, so you want to go there, you can imagine, and then ni bau sikit, sebenarnya banyak kan, betul tak? Million in one millimeter, we got like 10 to the power of 30, too many atoms. So this electron has to go through this. So electron tu nak kena go through this. So when the electron traveling, it want to go to the positive side, dia akan jalan kanan, dia akan hit this, dia akan pergi sini, hit this, dia akan hit that, lepas tu dia akan pergi. Okay, so it depends. So this structure, the lattice structure, depends on the material. Ada material lah, dia lagi, more complicated, more closely per spacing. So this easiness, mobility is how easy this electron will travel inside the semiconductor. And the symbol is ni mobility. I don't know, did you learn mobility in your first year? Saya pun tak tahu awak belajar ke tak. This electron, so the mobility is a measure of how easy or how difficult an electron or carriers will move inside a semiconductor material. Okay, so that's mobility. So this electron will if it moves, it will, if it moves even faster. So if you increase the what do you call it, the voltage, then it means that the electron will move faster, right? Because the attraction is more. So you can you imagine driving a car with a lot of obstacles like this? If you're driving faster, is it easier to maneuver or no?
Ada.
Harder, right? So macam kalau slow kat selekoh tu kan, if you are on very fast, it's easy, to just hit anything. So what happens is this electron will move, but it will hit the this nucleus, and then in the end there's a net movement of carriers to one side, then you have current. Okay, so going back, so mobility is that. So this mobility is a factor, is influenced by temperature. Okay, this mobility is influenced by temperature. How? Let's go back to this. Okay, now so how? Let's see. This electron, this atom over here, this atom over here, as you increase the temperature, what happens to the atom over here? The atom here, if you increase the temperature?
It vibrates.
Yes, it will start to vibrate. Okay, so can you imagine driving a car again? So electron is like the car. Driving a car and the obstacles are moving. It's not static. It's keep on moving like this. Is it easier or more difficult for you to drive it to here?
Difficult.
More difficult, right? So as you increase the temperature, the mobility will decrease. This mobility will decrease because so the mobility, because mobility are used in current. I give you 1 minute to find out equation relating mobility to current in semiconductor.
1 minute.
30 second lah. If you ask more, saya jadi 10 second. Okay. If you got it, let me know. The equation, current in a semiconductor, relationship with mobility with current. Jumpa tak? Mana Hambali dia? Hambali senyap je. Hambali, jumpa tak?
Current and trip velocity.
Jumpa? Aiman? Jumpa ke Aiman? Nama adik saya Aiman. Dia baru dapat anak yang ketiga. Ketiga. Aiman, ada ke? Ada ke?
Jumpa lagi.
Kenapa lambat sangat ni? Awak Google macam mana? Bukan 1 saat dia patut dapat. Awak Google. Cuba tak keluar. Tak ada ke? Oh ni saya pula kena Google. Awak tak jumpa ni? Kalau tak jumpa.
Relationship between current and drift
Faiz
velocity.
pun tak jumpa.
Ni ni equation current je, I equals Q over T, and then J equals to I over A.
Wah ni saya 1 saat pun dah jumpa. Apa dia awak cari ni? Saya pun tak tahu awak cari apa. Kenapa awak tak jumpa? Awak tak cari Wikipedia pun dah ada. Awak nampak tak skrin saya? Saya tak nampak skrin saya. Awak nampak skrin apa? Awak nampak apa? Tengok balik. Tak cari tak. Awak nampak ke skrin saya tadi?
Tadi nampak.
Okay. So this is the equation, brothers and sisters, which I don't know why you couldn't get this. So what is J? What is J? J
Current
is-
density.
Yes, current density. What's the equation for J? J equals to I over
A.
Eh,
Area.
Okay. So this that's current density is the same. So you just here you multiply by A, you get the current. So this is the equation over here, J, E. So this is, so when you talk about semiconductor, you have 2 types of carriers. So you can have current due to electron and current due to hole. So you have 2 equations for semiconductor in semiconductor material or device. So this is JE, E for the current due to electron. So that is equals to this, E is the electronic charge. What does electronic charge means?
The charge of electron minus 1 point. What is it? The charge of electron.
So it's the charge of one single electron. So
Yeah.
E is the charge of the single electron. N is what? N is the number of electron. So N is the number of electron, and this Vd is the drift velocity. Drift velocity. So imagine this electron will travel to here with a certain velocity. So the current is a measure of the velocity times the number of electron that you have and the charge of electron. Okay. So but this drift velocity is a function of me. So Vd equals to mobility times electric field. Okay. So the drift velocity, the velocity of this electron depends on the mobility of the electron in the semiconductor material and multiplied by electric field. So if as I mentioned, right, if you increase the voltage, the velocity will increase. Therefore, the current will increase. Okay, so that's the relationship. So that's why for us mobility is important, because it will affect the current. If it doesn't affect anything, we don't care. If anything in the semiconductor, it doesn't affect anything, we don't care. But the problem is, this mobility will affect the current. So if I increase the temperature, what happens to the current?
Decreases.
Hmm?
Decreases.
It will decrease. So as a when you're designing a semiconductor device, you know that if you increase the temperature, the problem is the current will decrease. So but in terms of the free carriers, as you increase the temperature, what happens to the free carriers?
Increase.
It will increase. How about if the free carriers increase, what happens to the current? If you have more free carriers, what happens to the current?
Decrease.
Apa?
Decrease.
Increase lah kan ini tadi. Ni. You increase N, you increase J. N is the number of free electrons. Okay. So can you see in one situation you have two conflicting happening. The mobility will reduce the current. However, the free carriers will increase the current. So what happens in the end? What happens in the end, it will depend on the situation. How high is the temperature? How high is the temperature and also the material. So in the end, if this kind of question come up, you need to discuss and think what you think best. It might be right, it might be wrong, but the way you justify in your exam, I will accept. You understand? So you're supposed to give, when I give one situation, maybe a few things will happen in one situation. So you need to recall, kalau temperature naik, yang ni naik, ni turun ni, kenapa effect. So normally in the exam it will be like that. You need to gather one situation, but there are many components that you need to think of. Okay. So it means, therefore, when temperature will affect the mobility of the carrier, of the free electron of the hole. So this process, let's talk about velocity saturation and lattice scattering, or phonon scattering. Apa benda ni? So let's go back here. So if you look at here, what happen, the process when you if you this is the atom vibrates as you increase the temperature, this electron will travel and they can hit this. The probability of its hitting the atom is higher when the temperature increase, and this what we call it, this process where these electron are hitting all this atom is called lattice scattering. Okay, this process is called lattice scattering. The electron are being scattered by the lattice. Ini nama dia lattice scattering. So so this lattice scattering, one name of it, another name of it, we can call it apa nama dia? We can call it also phonon scattering. It's the same thing. Phonon scattering, because phonon, right? The temperature. What happens is this temperature will affect the atom vibration. So they will have phonon. If you want to imagine there's a phonon here, so this phonon will scatter the electron. So lattice scattering and phonon scattering is the same thing. You can use either word in the exam.
Madam,
Yes.
this will occur when temperature increase only.
At room temperature or at 0 Kelvin, of course nothing happens. No carrier will move. But as you increase the temperature, when you have this net movement of electron, even at low temperature it will occur, sebab dia akan ada dah 1-2 akan hit. But the lattice scattering is very low, rendah. So as you increase the temperature, it becomes more and more dominant. The word is dominant. At room temperature, maybe it doesn't matter much. Lattice scattering, phonon scattering, not much effect. But if you increase maybe 40 degrees, 50 degrees after room temperature, then this lattice scattering and phonon scattering will become more dominant. Okay? Any more questions? What is velocity saturation? Okay, mana graf tu? Tak ada graf tu. Tak ada. Okay, kita draw sikit. If we draw the graph of kita draw a graph of velocity, the drift velocity versus the electric field. Nampak? So if you have this, if you plotted, if you go do experiment, you measure the velocity of the carrier and you against electric field. What's electric field again? Is that this, okay? Is voltage versus distance. So it means as you increase the electric field over here, you increase the voltage. Okay. So what happens as you increase the voltage? It means that if you increase the voltage, the electron will be attracted faster to the positive side, or if it's the hole, it will be attracted faster to the negative side. So you will expect the graph will look like this. As you increase the electric field, the drift velocity will increase, right? Betul. But as I mentioned, everything in life has limit, including the velocity and the mobility of the carrier. So at very high electric field, dia akan jadi begini. And this is called velocity saturation. This is velocity saturation. So at one point, if you increase further the electric field, the electron will no longer move faster. Why? Because of lattice scattering and phonon scattering. And this is occur at each material have its own maximum value before it enters velocity saturation. Okay, so look here. So meaning that when velocity saturation occurs, it means that you have too many of this lattice scattering. So further increase of the electric field or the voltage will no longer increase the velocity. Dia dah sibuk langgar banyak benda dah. Okay, any question? So you understand, right? The concept of velocity saturation, lattice scattering. Ada soalan, Aiman?
Adam,
Ya, tu. Aina,
can you repeat on the graph too?
what do you want me to repeat?
The point where it reached velocity saturation, velocity saturation though.
So what you want me to repeat?
I am digesting from the first word of velocity saturation just now, and when you explain about the graph, I am lost.
Okay, Faiz, explain the graph.
Okay, so as you increases the electric field, so according to the formula, technically the velocity also will increase. However, as Madam said, everything in life has a limit, because after a certain point, increasing the electric field will no longer increase the velocity of the carrier. Hence the word saturation, velocity saturation, right? This is due to the scattering, because even if you increases the electric field, the electron keeps sitting on the nucleus of the materials. So the net movement of the electron is limited to that point because the collision between electron and the nucleus.
Boleh, Aina. Okay, thank you, Faiz. Any more question?
Is there well, does scientists ever success in, sorry, let me rephrase. Can electron reach speed of light?
Can electron reach the speed of light?
Yeah. Can its velocity reach speed of light?
No.
No.
Nothing can be the same or faster than than light. Cannot.
Well, light is basically photon, right? So speed of light, we are referring to photon velocity.
Yes.
Okay.
So So photon are not the same as the carrier, electron or hole.
Okay.
Okay. Electron hole have mass, which is a bit heavy. So they cannot travel as fast as the light. Okay. So that's why in the end, in terms of if you use a unify should be faster than the conventional. Before this kita panggil apa? Apa internet kita pakai kat rumah tu yang ni
Remix.
tu panggil apa?
Dial up.
Remix.
Apa?
Dial up.
Dial up kan. Dial up tu dia orang pakai electron and hole. Dia pakai conductor, dia pakai copper conductor. So dia ada limit selaju mana dia boleh pergi. Tapi Unify pakai fiber optic, dia pakai cahaya. So memang laju. Okay. So nanti in the future, you know, all this computer, they are hoping that all our computer be using light as the as a carrier instead of electron hole. Tak tahulah bila. Kalau yang tu jadi melaju gila lah semua dia. Right? Tapi at the moment, the technology tak sampai tahap tu lagi. Okay. But that's the cita-cita. Cita-cita orang kita semua nak laju. Okay, so then the next part is we want to learn about conductivity. What is conductivity? Ni first year tadi kan belajar ni. Conductivity apa? Kalau tak Google tak jawab.
Kira orang lain pula.
Orang lain pula. Siapa nak jawab? Awak Hambali tak nampak muka awak dah. Awak tutup ke? Okay. Hambali, conductivity apa?
The ability for the certain material to let current flow.
What is conductivity in your own words?
Let the current flow.
Huh? It's a measure of how is a conductivity ialah is a how much current how much the carrier can travel inside the material. So conductivity, what's the can you find an equation? I give you 1 second. No, okay lah, 10 seconds to find the relationship between conductivity and mobility. 10. Jumpa Aina.
Product of mobility and carrier concentration. Carrier concentration.
Saya tak Google lagi ni, saya bagi awak cari dulu. Bila saya dah cari tu, awak dah fail lah. Awak tak jumpa.
Yeah, that was the technical name for the JE earlier.
It's
Electron induced current.
The current density in semiconductor tu je.
Oh, current density.
J is just current density.
Oh, sorry. Okay. So I believe
Electron. J.
product of mobility and carrier concentration.
Equation cepat. Tak ada ke? Ataupun tak kalau tak boleh bagi equation, bagilah apa nama dia punya relationship between conductivity and mobility. Conductivity is the inverse of resistivity.
Product of carrier concentration.
Tak ada orang jumpa ke ni? Azam? Oh, Azam. Jumpa tak?
Kod, madam.
Jumpa?
Kod lah.
Okay, so what is it?
I share my screen.
Okay, sekejap saya share bagi. Okay, boleh? Saya kena stop sharing dulu. Okay, go on. So
Is it this one?
is it this one? Okay, good. So okay. So what's the equation? So the symbol for apa ni? The symbol for conductivity is like that. Sigma ni. And Q mobility. So you have okay. So from here you know what's N and I is the intrinsic. If this is Ni is if this is the intrinsic apa nama ni material. If it's not intrinsic, then N will be the number of free carriers, right? Okay, Q is the sometimes they use Q, sometimes you use E. Yeah, electronic charge. Sometimes they use E, sometimes they use Q. It's the same thing. Okay, it's the same thing. Jangan confused. And then times the mobility. Okay, thank you guys. Stop sharing. So I will share my screen again. Okay, so this is the equation. So the conductivity is a function directly proportional to the mobility. So remember, so this has to do with this, right? Which is the mobility is affected by temperature. If the mobility is affected by temperature, so it means that conductivity will affected by temperature. What's the relationship between conductivity and current? What's the relationship between conductivity and current?
Directly.
Times?
Directly proportional.
Times what's the
Directly, madam.
equation? You can already derive from here.
Yeah.
Yang sebelum mana yang slide satu lagi yang saya tu. So conductivity tadi apa? Ni kan. This is conductivity, right? Yes or no?
Everything.
Yes or no? Hello.
E and Q. Oh yeah, yeah.
Right. So this is the same as I'm writing conductivity times electric field. Okay. So I can find the current using like this or like this, or I can write in terms of conductivity. So when the conductivity times electric field, you get the electric current. The current inside the semiconductor devices or materials. So sometimes in the paper in the question I will talk about mobility, sometimes about conductivity, sometimes about current. So make sure you know the relationship. Okay, make sure you know the relationship. So conductivity is proportional to mobility and number of electrons or holes. How about the resistivity with temperature? You know resistivity is what? What is resistivity? Right? So rho is the resistivity, is the resistance of that material times the length divided by the area. So this is the resistivity. So my question to you, does the resistivity of a semiconductor change with temperature or no? If yes, how? If no, why?
Resistance equals to
Siapa nak tolong jawab?
I. Hang on.
I think, can I try, madam?
Sure.
Resistivity will increase if the temperature increase, because when temperature increase, the atom will vibrate more and will make it harder for the electron to pass through the atom.
Okay, so it means that as temperature increase, what happens is the mobility will decrease, right? This mobility will decrease. So therefore, the decrease, the conductivity will decrease, right? And since the resistivity is inversely proportional with the conductivity, therefore resistivity will increase. So the answer is yes. How it is increased? Because of the mobility decrease due to the lattice cathode. So in semiconductor, it's very sensitive to temperature. There are many things that are affected by temperature in semiconductor. You can say number one, mobility will affected. The number of free carriers will be affected. The resistivity will also be affected, which in the end translate to the resistance. So that's why when we design the semiconductor, we need to be careful with the temperature. So that it won't change very much. So that in the end, the performance of the semiconductor device or material will not change. Okay. Next question. Does resistivity changes with impurity concentration? It means the doping.
Absolutely.
Does it change or no? If yes, why? If no, why?
Siapa nak try?
Huh?
Siapa nak try?
It will increase
Aiman kata will increase.
because there will be more atom, so the electron will be less mobile.
Okay, Aiman kata dia akan increase. Resistivity will increase with doping. So Aiman kata orang lain?
The opposite.
Huh?
I'm the opposite. The resistivity will change, but it will decreases as the doping concentration increases.
Why?
Basically, because higher doping means higher number of free carriers, right? And higher free carriers mean higher current. Thus, lower resistivity.
Okay. So yang mana betul Azam? Faiz ke Aiman?
Macam Faiz.
Oh, Azam rasa Faiz. Salihin?
Saya tak dapat tangkap lagi.
Apa yang tak dapat tangkap?
Soalan tu.
Oh, soalan tu dapat tangkap. Boleh tanya, awak nak soalan tu buat semula?
Does resistivity change due to
Impurity concentration.
impurity concentration?
Jadi, apa yang tak dapat tangkap? Oh, tak dapat.
Saya decrease lah itu.
Oh, so decrease. So,
Salah tu. Saya tak boleh rasa minum saya.
tak ada rasa.
Saya tak mesti minum.
If you doping a material more, does the resistivity increase or decrease? That's the question. Like if you introduce more aluminium into silicon, will it increase the resistivity or not?
I think the resistivity will increase because atom lagi banyak.
Okay, dia kat dia argument. Sure.
Yeah.
Apa tak dengar? So,
I say that resistance will increase.
Why?
Because there's many atoms, so dia sesak-sesak jam.
Aina, so awak sama dengan Aiman lah. You're thinking like Aiman. So kita ada 2 against 2. Tanya Aina pula. What do you think?
It will increase.
So awak pun sama dengan Aiman lah. So Najwa, hamba ni tutup muka tu kenapa? Najwa?
Decrease.
Apa? Decrease? Decrease. Awak pun kata decrease mana nak follow Faiz. Ambali.
Tiga.
Ambali.
Ya.
Ha? Apa?
Decrease.
Tak dengar.
Kurang.
Decrease. Yeah.
Decrease.
Oh, okay, dia decrease. So, Faiz. Okay. Okay, let me tell you. Interesting. So, interesting because I'm happy you actually thinking, awak berfikir. And actually, dua-dua tak salah. Okay. So, dua-dua tak salah tapi dia macam ada catch dia. So, sebab tu kalau dah semiconductor device ni, kalau kita berfikir je, awak akan dapat banyak masalah dalam exam. Itu yang susah pun. Tapi masalah bila awak berfikir, awak tak berfikir satu. Awak berfikir tu tak logik. Memang awak menghafal, mulalah awak mengaku kat situ. Masa tu lah awak tak dapat masalah. Sebab saya tahu tak logik. You know, if you use your thinking, you should be able to answer many things in this part. Okay, mana nak cerita tadi ya? Yang mana buat apa? So memang it's true. As you impurity concentration means you put doping. Doping means you increase the free carriers. When you increase the free carriers, then because this is conductivity, you increase the free carriers. It means that you are increasing this, what do you call it? Increasing the conductivity. Therefore, you decrease the resistivity. Betul? Resistivity. So yang Faiz jawab. Itu betul. So yang Aiman jawab pun betul sebabnya as you increase the if you increase the what do you call it, the impurity concentration, which is the doping, you actually betul you are adding more. Remember when we dope, kita akan add, dia kadang dia ada duduk kat sini interstitial, betul tak? Dia ada interstitial ataupun substitial, kita cerita kan. Ya, kadang-kadang dia akan duduk kat sini. Can you imagine nak bawa kereta lagi payah. So in the end, it will reduce the mobility, hence therefore it will increase the resistivity. Now, how do we choose which one? This it depends on, so dia bergantung pada limit how much actually the doping concentration. Then next question you should ask, how much is doping you add? If it's a normal doping that you add for a normal device, the second one, Aiman's answer will not be dominant. The dominant will be there more number of free carriers, therefore resistivity will decrease. Tapi if you add, that's why you need to read the question carefully. If you add a lot, like doesn't make sense a lot, then you have problem of this lattice scattering, and that will be dominant. Therefore, it will reduce the number, it will reduce the conductivity, therefore increase the resistivity. Boleh. So in exam, let's say if in the exam you read, it's not clear, it's not even stated what's the doping and everything, then the best is for you to you need to assume. You kena tulis. So assuming that the doping concentration, and you answer. Then you get full mark. If you need to assume if it's not stated there. If it's stated there, you have to take that as a fact. If it's not stated there, awak nak pakai yang mana, I will give both answer correct. Macam soalan saya tadi, saya tak beritahu pun doping. So you be correct, should be correct. Both. Okay? Boleh? Ada soalan? Ada soalan?
Madam.
Ya?
Madam. Let me recap. For small impurities concentration, the Far East way is more dominant, but is a huge impurity concentration. The Aiman way is dominant, is it?
Yeah.
Okay.
Okay, because dia dua-dua akan happen. These two mechanism will occur. But in semiconductor, it's always about which one is the dominant mechanism. There are many things that will occur at the same time, but which one is the dominant? That's the key. So in the end, the dominant will take over. Yang kita akan nampak final result dia is the dominant mechanism. Okay. 12.50. Okay, kita masuk diffusion drift lagi. Okay, so I want you to go and read about diffusion and drift. Apa benda dua ni? Shouldn't take long. Lepas tu kita akan pergi current. So diffusion and drift, what is it? And then drift current, diffusion current. Lepas tu kita masuk device. So sebelum masuk device akan ada quiz satu. Okay. Sebelum nak masuk device, PN junction, we'll do one quiz to cover this whatever we learned just now. Selama ni. Okay. Any question?
Excuse me.
No? Everybody understand? Kalau tak faham, sila tanya. And then you kena faham tau, jangan hafal. Sebabnya dia multifaceted. Maknanya dalam ni dia akan banyak-banyak soalan tu. You kena bawa beberapa theory in order to answer one question. And dia interrelated. Okay, tak ada soalan? Alright. I think that's good. So we'll continue on Thursday, inshallah. Okay, can we close the class with the doa?
Madam,
Yeah.
you haven't give the password.
Oh,
Attendance.
kenapa tak tanya?
Oops.
The password is for today is
Procrastination.
procrastination. Berilah yang positif sikit. We'll say ikhlas.
There you go.
So sama-samalah kita
Apa,
mengikhlaskan
madam?
kita. Ikhlas.
Ikhlas.
Ikhlas sebutan orang Melayu ikhlas. Dia sort. Ikhlas. Okay, siapa nak baca doa? Saya ada meeting lain pula ni. Berdek-dek meeting saya. Siapa giliran siapa ni baca doa ni? Siapa baru baca sekali? Sepatutnya dah masuk round 2 dah. Saya ada meeting ni, cepatlah.
Ya, madam.
Siapa?
Saya.
Siapa saya? Saya
Aiman.
beritahu dah WhatsApp bagi tazkirah itu, you know.
Aiman,
Jangan
Aiman.
sebut saya.
Eh.
Saya siapa?
Aiman.
Ha?
Aiman.
Aiman.
Bismillahirrahmanirrahim. Allahumma inna nas'aluka ilman nafi'a wa rizqan thayyiba wa amalan mutaqabbala. Subhanakallah wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Wal 'asr innal insana lafi khusr illa alladhina amanu wa 'amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Wa sallallahu ala sayyidina Muhammad wa ala alihi wa sahbihi wa barik wasallam walhamdulillahi rabbil alamin.
Alhamdulillah. Thank you, Aiman. So, bagus. Baca doa semua orang. Betul boleh tukar-tukar doa. Ni saja nak buat challenging. So, jangan doa sama. Takkanlah brother doa sama dalam pendek 2 saat je doa. You know, patutnya doa. Saya tak suruh, okay, lepas saya suruh baca doa lepas semayang. Kita buat doa iftitah ke. Ya, baru je.
Madam.
Tak lepas nak kahwin.
Boleh upload video tak, madam?
Untuk yang ni? Yang sebelum ni saya dah upload kan?
Ada.
Yang ni insyaAllah ingatkan saya. Sebab saya ada meeting terus ni. Mungkin petang ke apa ke remind saya pagi ni ke. Okay?
Okay, madam.
Alright. So see you on Thursday insyaAllah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Have a nice day, madam.